Answers your question, right? Okay. All right. Now this is the magnitude. We don't have the direction yet. We are dealing with vectors. So we need to figure out the direction of it. I know it's going off like that. So let's establish I hat, j hat. Now, if you're a fan of adding vectors using law of sines, law of cosines, and doing it that way, more power to you. But that's not the way we're going to do it right here. But we do need to figure out what is that angle. I'll just call this theta sub 2. How do we find that angle?
That's the same angle as between the hypotenuse and the 2 centimeter length?
Yeah,
Okay.
that one.
So how do you find that angle?
Math.
Math?
A trig function.
Yes, that is true. I will find that.
And do we use, does it need to be in degrees or radians? Degrees.
As long as we're consistent.
Okay.
I prefer degrees just because I've been brainwashed that way, but
Okay.
Just use cosine inverse of 2 over square root 13.
sure. So theta 2 is the arc cosine of 2 over the square root of 13.
Got 56.3 degrees.
Something like that.
All right, so we seem to have agreement there. So therefore, the direction is going to be cosine of 56.3 degrees I hat plus sine of 56.3 degrees j hat. Given I did the I hat, j hat, the traditional right and up. That is a calculator exercise. We'll have something I hat with something j hat. If anyone has done that calculation already, I will take it.
I have the left part of it, which is 83.07 Newton.
This right here?
Yep,
83.7.
07. Well, we can just go 1.
You want the right side? Or do you want all of it?
All of it.
Okay, times 83.07. Is that what that says?
Yep, that's 83.07.
I got 115.2.
Wait, how'd you get 115.2?
I don't know, man. My brain hurts.
And you multiply the value on the left and distribute it to the
Yes.
the I hat and then to the j hat. Okay.
Yes.
Gotcha.
So assuming 83.07 is correct, that times the cosine of 56.3 will
Is
give us
46.09.
Newton's I hat.
Oh, stupid.
And then 38.35 j hat.
Oh yeah, but radians.
Something's off.
I got 69.11.
For the second one?
Yeah.
Oh, my mistake. Yeah, I did a big math there.
Now, I knew something was off was because this angle is more than 45 degrees, so I know that the j component needed to be bigger than the I component, or vertical needed to be bigger than the horizontal.
Dr. Fox, if
Yes.
you put the, is that polar form for the I hat and j hat?
The polar form would be the 83.07 newtons, comma 56.3 degrees. That's polar form.
My mistake. The I hat j hat form, if you put that in parentheses and put the Newton outside of that, would that count for the units?
Yes.
Okay.
Yep. Now technically, this is an intermediate step, you don't have to write units in here at this point, but make sure that the units are there at the end. Also recognize cosine of 56.3 degrees is just 2 over the square root of 3. We didn't actually have to find the angle, that's 2 over the square root of 3, or 13. And sine is 3 over the square root of 13. So we could have just looked at the ratio. But we got there.
We got there, that's what matters.
That's right. Now we go through the similar process here. And there were complaints last semester of not being able to see the board well. Hector, can you see the board okay? I will take his nodding as a yes.
Okay. Not taking it as a no.
All right, so 99, 6e negative 6, 4e negative 6 over
0.001.
yes. Times, and then we have the direction piece of it.
Why is the 4 positive?
This is the magnitude.
Oh,
The magnitude's a positive number.
okay.
That's probably one of the big mistakes for people who are doing the process correctly. The big mistake is leave the negative in here, then do an angle that reflects the fact that it's going in that direction. And so you're basically double counting. So I was gonna put the negative piece of it as part of the direction there.
I feel like that's usually easier. Just put
Pardon?
the sign at the end. Oh no, I was just saying, I think that's usually easier to just put the signs at the end.
Yeah.
I got the angle down there at 71 degrees.
Yep.
71.57.
All right, so if we're gonna go with 71.57 degrees, this becomes cosine of 75 point.
71, sorry.
Yeah, 71.
I wrote it correctly over there. 71.57 degrees I hat. And this is the point where I'm gonna take the direction into account minus sine of 71.57 degrees J hat.
Oh, that makes sense.
Yeah.
Degree symbol there. If we had expressed the angle as negative 71.57 degrees, because it is a fourth quadrant angle, we would have just put a plus here and the calculator would have given us the negative sign.
Is this how you would normally recommend setting up the axis for I hat, J hat?
Yeah, I mean, it depends on the situation, but, if I am dealing with not right triangles, as in, if I just looked at these three pieces right here, that's not a right triangle, then, yeah, I'll go for something standard.
Okay.
You could, I guess, have done something like that. But that, I think, would have been more complicated in the end. All right, so anyway, what do we get?
For the left side, negative 260. But I stopped them.
Oh, this piece right here?
Yeah.
Yeah, it's 216.
216?
And for I hat, it is negative 68.
68.
Newtons.
Yep.
Yep.
You said negative, it's not negative I had. I don't have the negative sign in front of the four.
I put that in my,
Yeah. So recognize that you throw the extra negative sign in there, so if you're gonna do that out of habit, then just make sure you double check at the end that the directions are correct.
So if I put the negative on the chart, the for charge, what do I do with the I hat and J hat?
You would work it through and then go, all right, so which one's positive, which one's negative?
Okay.
Because again, we're doing magnitude times the cosine, magnitude times the sine. This is the magnitude, so that negative sign should not actually be there.
Okay.
That negative sign is telling me the direction of the force is fourth quadrant.
And then it's negative 204.9.
All right, and so now we've got our F62 and our F64. We can find F6 just by, at this point, adding like parts. So we got the 46 and 68. Doing the fancy math here, that looks like 114 Newton xi hat. And then I've got that minus the 69.11.
Why'd that just delete your first one?
Sorry?
Your first one just got like deleted. I watched it go away.
It has done that before. I forget what the eccentricity is, or it just goes, we don't think you really want that one.
It knows physics.
That's right.
It knows what you want.
And so, let's see, minus 71. $134.8. No, 135.8. I think.
Yeah.
Yep.
Or, so those who really don't like writing units because of course, the childhood scars. Then you only have to write it once.
That's pretty cool.
It's a genius.
If you are gonna write it once, please, parentheses, don't forget the parentheses. And if you think that's just my eccentricity, this is particle data group, which is sort of the governing body of all things picky unit in physics. They say put the parentheses in.
Well, they say it, yeah.
That's right.
Must be for it.
I trust them.
Tilt that a little bit. Yes.
What would the A be in this situation? For the theta to down, yeah.
What is the
The
A?
Oh, for cosine, arc cosine?
yeah. It's
Oh, yeah.
That's
Okay.
that's like an inverse cosine.
Arc cosine of 2 over radical 13, or as your calculator would have it, cosine negative 1.
Oh, okay.
I really don't care for this notation. I understand what it means. I don't care for this because to me, that looks like you're taking a reciprocal.
So A be the inverse.
A is just arc.
That's the inverse.
It's
Okay.
for arc cosine.
All right.
My calculator drops the RC and just writes A cos.
Thank you.
The TIs aren't cool enough to do that. William?
The 1 centimeter that was at the bottom, the
Yes.
meters squared, wouldn't that be an extra 0?
It should have been, it would be 10 centimeters squared. And then you move it over 4 places.
It's 10 centimeters.
Okay. Would it help if I stuck that extra 0 at the end? But the lesson is, as always, show your work. All right, other questions? Any questions?
I take it, I don't feel like I need to ask this, but I need to ask it. You take significant figures in this class pretty seriously? On
Yeah.
tests? Okay.
I take significant figures seriously, usually on the very first class, 251.
Okay.
And then never again.
Okay, sounds good.
Although I think I dropped that for the 8-week 251.
Nope. We had
Yeah, we had it.
figures.
Yeah, everyone should be familiar enough with significant figures that if they have to use them again, they will. But frankly, throughout my thesis and my dissertation, the word significant figures never came up.
Perfect.
At least we don't have to do uncertainty.
Yes,
Yep.
and we don't have to do uncertainty.
Sounds
That's also just a 251 thing. If you want to do uncertainties for your labs or whatever, please feel free to do it. Just don't expect me to grade it. All right. Any other questions before I erase and we do something else related to physics?
Yeah, I was gonna ask, I definitely think after the Monday and Tuesday lectures, I definitely understand this problem better. So we do more problems that we may have already covered the concept of how to solve them, but something from Monday or Tuesday.
Oh, where we're like the dy dx and the whole coming up with a dq
Yeah.
for finding force of a distribution. Okay. Any other questions about what we just did before I can finish erasing?
carry on.
It'll be right here if you need it later.
The eraser of knowledge.
Think of how much object knows.
Oh, true. That eraser knows way more than me, man. Oh, that's a tree.
So, I did it twice on Monday, and that's obviously enough for the universe. I want something different. Finite line segment. Uniform distribution, uniform charge distribution. Let's make it 3 meters long. We'll make that 1 meter to there. And we'll have Q is, it doesn't really matter, 4 microcoulombs, and little q here, or actually it's a collection of charges. Q2 is -3 microcoulombs. So this is ultimately it's twice the math that the first one is, because we don't have the symmetry in order to get rid of half of it. Is this the type of thing you were looking for, Pat?
Not
That.
We haven't done an example like this, right? Because this one lacks symmetry.
Yeah, we have not done, we've done half of it.
Yeah.
Yeah, we've done something.
I think that's a good problem.
Alright.
Sorry, just to clarify, is lambda, is that uniform, is that the charge distribution? What does that represent?
That's the charge density, linear charge density. So lambda, I know is Q over L, which would also, if it's uniform, yeah. Now, there's 2 approaches that we can take on this. One approach is start treating it basically like we did before. The other approach is to actually break it into 2 problems, solve half of it. So basically ignore that for the first part, solve that half, and then apply what we've derived there for doing the other half, the other part. So it doesn't matter which approach that we take, this as long as you apply the numbers right. So, any preference?
So it doesn't matter where it is on the line?
Oh, it does matter.
Yeah, I was wondering about that.
You just wanna know everything.
Yeah, the answer would be nice.
Let's, 2 meters. I assume you feel complete now.
Yeah.
Okay.
I'll take it, yeah.
Okay. I assume you'll feel complete as soon as we come up with an answer.
Then I will.
So I wanna know, what is the force on Q2? All right, any preference for the approach? Then let's do it similar to last time. I established some DQ here. I don't have a coordinate system yet really set up. So I'm gonna make this x equals 0. So that would be x equals 1 and x equals -2. I could have also made this 0 and that 3. I mean, in the end, again, if you apply the numbers right, it doesn't matter which way you do it. But my psyche says, let's just make x equals 0 at the point on the line segment closest to Q2. Probably should establish an I hat and J hat. And out of lack of thinking, I'm going for the traditional right and up. All right, so I know that the force from dq, so we're actually dealing with the differential of the force, it's going to be towards dq because the charges are opposite signs. And so I've got k q2 dq over, that would be r squared